Hello world and welcome back to another video. In this video I wanted to kind of step outside the norm and not fire up my virtual machine, my Linux Ubuntu instance that has ERDPie and Visual Studio Code installed in it. But instead this time I kind of wanted to explore quickly deploying, compiling and deploying smart contracts for Elrond using their playground. Um, and it's a pretty interesting interface, I must say. And the link to it is right here. And you can think of this as a kind of similar to the Ethereum's remix, which is like an online IDE that you can use to quickly, um, pretty much um, compose and write up smart contracts on the fly and quickly deploy it. Now, with some of you may or may not know, but with Ethereum's online IDE with Remix, um, I believe it runs on the in a sandbox environment with its own testnet installed, I believe. Um, yeah, I think for the most part, that's why you're able to generate wallets really quickly within this interface and, you know, do things like that. Um, and then from there, you can kind of just deploy it on out. And then on here, it already connects you with wallets that has connected ETH to pay for gas fees and test out your tokens and wallets to do it with. With the Elrond online IDE though, you do have to log in with a existing wallet. So you have to kind of create your own dev wallet, kind of like what we've been used to in previous videos here. And once you're on those wallets, you would have to grab tokens from the faucet within your wallet in order to play around here. So it is kind of a two-step process, though. Let's see, so you would have to go here, fill out, you know, all the questionnaires. I believe these count, right? Wow, these questions, they're killing me. And then I already claimed it, but you would get your tokens from here, and that way you can interact with the Elrond Playground here. Now, for this tutorial, I just kind of want to run through and doing kind of like a hello world, very simple, broad, and basic DApp. Um, a lot of the documentation that the Elrond team puts together can be a little bit overwhelming, I feel, and I don't think they have um, in mind a lot of the community that may not be heavily tech savvy as myself. But I'll provide all these links in the description of the video, but here's the overview on their Docs Elrond website. It kind of runs through a lot of the sample snippets of code, smart contracts, and dApps to kind of play around with. This one was a good one, the crowdfunding documentation. This kind of goes through a deep dive of creating a smart contract, deploying it out, also doing the Mondos testing of the script before deploying, making sure, or building just to make sure everything looks good. It's pretty extensive, pretty nice, but again, I think this is going a little bit over the heads of a lot of the common folk that are out there. Another thing that, hate to digress, but I think it is relevant to our endeavors of trying to figure out the Elrond blockchain, but that is definitely getting to know Rust, since the Elrond team is heavily encouraging everyone to use Rust, since it's their core programming language that they decided to run with. Particularly because of the WebAssembly architecture and language of the code. They believe that's a feature of Web3 and the internet, and they believe that Rust does it. I mean, as far as the programming language, pretty nice. It's robust. It does some pretty good error handling and garbage collection, unlike and utilization of resources, unlike the other scripting languages where you have to be conscious of that as you're going. But I'll provide this link. It kind of goes through just going through Rust and learning the syntax, because a lot of this stuff you can find and translate over to a lot of the smart contracts that you may come across or start coding yourself. For example, the integer types, you'll see that a lot. Um, Another thing to take a look at too, and I'll make my way over, is translates into a lot of the structure that we see within Elrond smart contracts, and you'll see this within their smart contracts as well. What's publicly accessible, private endpoints that you interact with to cause a smart contract to do something. And again, here's some more modules here that we may or may not come to know. Um, you also find some documentation on best practices, and this is again handling data types. Elrond is trying, part of their technology is they minimize the use of processing time, since that in the end that's going to essentially cause resources to run on their end on the virtual machine on the network, as well as high gas fees to pay for that. So they do their best to minimize that as possible, and don't want to get too technical into it, and I don't claim to know it, but I think part of their infrastructure is that VM WASM that they have going on takes some of the burden off and allows a smart contract to be deployed and be as lightweight as possible. Um, so in exploring that, there was some data types that is a little bit um, specific or proprietary to Elrond that I did not find in Rust, but directly just out of the box for Rust languages and whatnot. But yeah, that can be found here as well. And I'll provide this here. So a lot of the data types you can kind of go through the repository and libraries of Rust, and you'll find the Elrond one, and you can see a little bit more into how to script and code for what's going on in the back end, how it's made. So I think this repository, I guess, that happens in the WASM in the back end is doing all of this and offloading it from our smart contract, having to load this in and run it. I believe. I could be wrong. Please, if I'm wrong on anything, feel free to correct me. I have no ego. It's all about being correct and providing correct information to the community. I don't believe in disinformation at all, and I'm always about truth, so please feel free. But it's very interesting if you want to take a look at some of the other things that Elrond has going on. You can just simply search for it. You can see all the things that they have. The WASM here. It's pretty cool stuff. Yeah. All right. So, without further ado, I think I covered all the info as well. I think you can also, if you feel free to, since we're diving down this hole, you can also check out the Node.js repositories for Elrond stuff too. They have some pretty cool stuff here. You can see what they have to offer. And eventually, a lot of this will provide links to the GitHub, so it's kind of round robin, full circle. But let's go ahead and jump right in. So, after logging in and grabbing your Faucet test tokens, we can go ahead and load up a very basic DApp from here. You may see these and it may seem very familiar to you, and it should. These are the smart contract examples that we played around with before, like the multi-sig in previous videos, right? It's probably one of the... I probably should have started with this video first before jumping into this behemoth, but I was trying to get that video out for the community. But for this one, we're just going to start with a very simple smart contract, and that's this adder one. And the adder is a very plain and basic um, smart contract template that we can use. It only loads up three things, and that is some of the header of the script that has to be there, and some of these functions down here. And we can see that we have the endpoint. This is where we interact with the smart contract. The initiate or initialize header to kind of, as this contract's deployed, this is the first step that kind of does. And, this is the storage. So it's storing a variable here that will interact throughout the smart contract. That's what I've come to decipher from all of this. So, just to kind of start this out, we can just deploy this simple smart contract, see if it compiles, I'm sorry. And if it compiles nicely, you should get a nice little hex hash thingy down here with no errors. If you get an error, it should look something like this. Any changes that you do, always save it, because I think it'll save it to memory. And there you can see errors in the debug output down here in the console there. So let's just go ahead and redo that. Okay. And let's compile. Okay, it looks good, no errors. Now let's do the deploy. So this should be very similar to some of the things that we've done in ERDPy and Visual Studio Code. So as we're deploying, it's asking for those arguments, and usually in that command line we'll have that flag for arguments or functions, and we usually put that here. So let's take a look though at the code, and it's asking for a big unit. So let's see, it's a sum, right? So let's just give it a... So if you look into seeing what type of data type this is, it's going to be a numerical one. And a lot of the smart contracts you may come across after looking and reviewing using those as examples, a lot of the times you're finding that it's interacting with numerical data. So I found that very difficult because I wanted to just do a basic hello world, as a lot of other first-time programmers usually have you run through, right? And we're going to do that in this video too. But figure just out of the box, use this template that they have, and they're using numerical values, integers, unsigned integers, whatnot. So let's go ahead and Let's give it a, let's give it, where's Bitcoin's price at today? Maybe we'll use that as a big number, since we can kind of say, I believe it's at 20, let's just say that. So that number I gave is going to set this sum value to equal Bitcoin's price today. That's what I typed in. Looks like I've got errors. I'm wondering if that has anything to do with the previous error. Nope. Looks good. Okay. Maybe it was a glitch. We can see our contract deployed, and we can interact with it now. So, you'll see this interactions right here, and they're listed right here. Much in the same way as in Remix, if you're familiar with Remix, on their IDE, when um, you may notice that once you deploy it, it's very similar to the way this is right here, right? You'll see the output be displayed here and all the ways we can interact with the smart contract that was here. You'll see that here as well. So as you remembered, as we deploy this, we set it up to Bitcoin's price. So if we do a get sum and just send the gas fees and pass in this argument as we did in ERDPie, because you're seeing here is the get sum, right? This will view what the variable has been set at. So at the time of deployment, I set it as the Bitcoin price, right? So let's take a look. Let's just go ahead and send in a query to view it. Now it's asking me to authorize a transaction. See the data that we're passing in. Smart contract that we're hitting against. And there it is. So if we go into our wallet, go into our transactions, you'll see get sum and the data. Now, to decipher this, since it's in hex or whatever data code language everyone's using, we have to use our handy dandy converter tool here. And I just go ahead and look for hex to string, right? Because this should be okay, right? So if we copy that in, nope. Oh, you know what? It's actually hexadecimal. There it is, and that was Bitcoin's price that we put it at. But let's say Bitcoin's price changed. So what we're going to have to do is interact with this contract, right? And we're going to add, right? So if you look here, the add function, how is this endpoint configured? So I guess endpoint is set up so that way we can interact and send stuff to the smart contract. So in this case, we're going to send another big value, and it'll, I guess, concatenate or add on to it, I assume. So let's give it a try. Let's add, and let's see that Bitcoin's price went up 200. You can see the C8 there. Let's send the transaction and see what happens. There we are. Go to the wallet. So we sent the add function, comes back with okay, everything checked out. So 2000, so let's see, just to make sure, I want to record this. Okay. We added 200 to it, right? Let's see what happens. So let's go ahead and get another inquiry. What is that sum variable set at now? Alright, we have a value here. And there it is. So we were able to update and add to the value. So that shows that the value can be added over time. Perfect. So that is pretty much the run-of-the-mill basic adder template that we ran through, the smart contract template on the playground here. You can also load this up in your ERD Pi under the templates like the smart contract videos I had you walk through. But let's change this up a bit. So instead of sending values, let's say that we actually just want to interact with strings or just words, right? The Elrond team, I notice a lot of their smart contracts don't interact with strings as much as they do with the numbers. And I think it is due to the way that I mentioned before, where they don't want to overwhelm the resources of the blockchain to make us, the end users, pay excessive gas fees over time. Which is great, I get it. But again, it's just these, little things that we just, only through examples and videos like this or some of the documentation, trials and errors that you really start to figure out for yourself. But it's painstaking, grueling, it's not easy, and that's why I feel that I took it upon myself to help the community out here. So let's go ahead and change this. Let's go ahead and just say, hello world, right? This is something basic that most, coders start off with, right? Instead of sum, right? Let's go ahead and just say message, because we're not dealing with numbers, we want to deal with words, right? Right. Now, obviously, we can't really handle addition, multiplication, all that kind of things with strings per se. So, for this, we're just going to change this up a bit. So let's also change this, function name here to get message instead. So that way, this will replace, these right here. Right? Another thing we're going to do is, instead of add, right, we're not going to add, but we're going to update the message. Alright, there we are. So far, so good. It's looking pretty good. Let's just do a save real quick. Okay, and let us take a look some more here. So we have a message, all throughout. Now the other item is, looking at the function here, we can start seeing how the rest of the smart contracts kind of set up. In Rust, they kind of program like this, and you may also see something similar with other scripting languages, like React or something like that. But inside these parentheses, you kind of start seeing how they're setting up variables and the data types of that variable that it's going to be used and how it's going to be interacted with and how it should be treated. So for strings, however, we're not going to use this this big units, not numbers. Instead, it's this manage buffer, which I showed you in that Rust documentation. for Elrond, that's how they treat strings. So we're just going to switch that out for all of these, right? And instead of dealing with values here, what I'm going to do is handle this as, you know, relating to messages, right? So instead of value, we'll say initial message, and initial message. There we go. There's another value down here too. So I'm just going to call this one message update, and we'll just call that message update. Okay. Now, let's see. So instead of update here, though, we're going to change this around a little bit and make this to be set. And we're going to get rid of all this because not really using the same interaction with strings than we do with the big unit, right? So I'm going to Control S to save this, save our work so far. All right, it's looking good. All right, and we set the message. That's when at the time of deployment. So I'm thinking, so message managed, everything's looking good. All right, so let's try and compile and see if we got any errors. Alright, I guess that's looking good. Got an output. Fantastic. So let's go ahead and deploy it now. And instead of doing numbers, I mean, we could pass numbers, but notice we can select string right here. Now, if I try to deploy without a string, it's going to say you need to input a value, we need an argument on the time of deployment. Okay, well, fine. We'll just go ahead and say hello world. And give it a moment. I'm just going to copy this and add it to the notes so that way I can update the repo for you with the runbook. Every version of the code as we do this step by step. There we go. So we have that and interaction. Now notice how they've changed, right? So let's go ahead and get the message. Fantastic. There we are. Okay, get message. And we can see that the data is different. And if we try to do that for decimal, you'll see that's just ludicrous. It's not what we typed in, so it's not that. So it must be a string. And there you see, hello world. Fantastic. Well, let's go ahead and try and update this. Right? And it's a string. And also keep in mind the gas fees. You may start to see that climb up with more words that you use. Or more data. Alright. Let's take a look. Okay, sent our message to update it. Looks okay. Now let's pass a query again. time. And let's see, you can see that that looks a little chunkier. And there you are. Fantastic. Everything's looking good. Now, let's say that instead of the initial deployment, you don't want to pass in an argument, you just want it to be initially set up with something by default, not have to always send in an argument. We can do that by passing in a variation of snippets of code that I have here. And we'll go ahead and use a couple of syntaxes I found here. And that is this one. And you notice that I am setting the variable to be default right here, your string. In this case, let's just say hello world to keep it consistent, right? Let's set that up. Okay, so we got a new compile. Let's deploy. Now, to test this, I'm not going to pass any arguments. So let's try it out. Just deploying the contract with no arguments passed. Looks like we have some errors here. And it's not displaying anything. Let's see what's happening here. Alright, now let's do a test again. Should be a new contract here. That's weird. Looks like, check the, that was weird. And there you go. Another variation of this actually can also be used as this one. So let me just copy that for the runbook for the YouTube video. Okay. And the other variation of this can also, it's much cleaner I think, is using this one. See if this compiles. Fantastic. Let's see. see if this LN to F changes. And again, you don't need to set this argument. So this is a great way to preset the variable, I guess is a good way to put it. Could be wrong, I don't know the technical jargon, but you preset the variable with the value, and that way you can update it after that. All right, let's take a look. Did that not go through? It's very odd. I wonder... That's weird. I wonder if something's going on where the previous contract's in memory or something. Looks like it's still using the same code, 808. Okay, here we go. This looks better. Very odd. Maybe I'm moving too fast here. For once. Yeah, there it is. And you can see that if we interact with it, it should update. Looks like we've got an error here. I bet you it is from our update message containing special characters. Not enough gas. Interesting. Makes sense. Let's try this again. Alright. You can see how much more for the bytes. Alright, let's see if this works this time. Alright. Log right. Update message. Okay. So if we take a look at our smart contract, it looks like the playground's a smart contract and it signs it off every time we mint it or interact with it. That's pretty cool. Alright, let's go ahead and get the message then. this insanely long string. There it is. Fantastic. So we pretty much ran through a lot of these examples here. One other thing that Martin has brought up in the community that I thought was interesting too was a way to have the contract reset itself. So after, I guess, using it, you can use this to reset the message back to hello world. Found that very interesting too. And you'll just pass in the reset command and it'll go ahead and switch it out. I think that's pretty cool too. I'll give you an assignment. Go ahead and try this out and see if it works and let us know. Other than that, that's pretty much the scope of the video. I hope you found it very useful. Do a basic hello world smart contract and using the Elrond Playground. If there's any corrections, recommendations, feedback, please provide it in the comment section down below. Hit the like, subscribe, and notification bell. And looking to see and hear from you all soon. Thanks again and have a good day.